right, this is 8.4a, part 3 of 3, and this is when we're going to talk about graphing sine and cosine functions. So there are just a few steps, I don't know if you want to write these down, and on how to do this. The first step, and this is the absolute most critical step, is to find the amplitude in the period. That's going to tell you how far apart things are and how tall they are. Then we're going to talk about finding the x-intercepts and the maximum and the minimum. But once you have these two things, the rest is pretty easy. It just kind of falls into place. Okay, so for example, just the regular old y equals sine of x function. Okay, so my amplitude is 1. My period is 2 pi over 1, right? Remember, the period is 2 pi over b. Okay, so 2 pi over 1 is 2 pi. So this is what we see. This is just the basic graph. All right. So I know that it's going to go from 1 to -1. And what tells me that is my amplitude. My amplitude is 1. So 1 up, 1 down. And my period, this is when it starts to repeat itself. So I've got 2 pi over here. And I've got to fit everything in to that point. Okay, so I've got my period. I'm going to cut it in half 3 times. So here's the middle. Half of 2 pi is pi. Half of that is pi over 2. And half between these two, so I've got 1/2, 2 halves, 3 halves, or 3 pi over 2. Okay, and as you recall, hopefully you recall, that the sine function is the one that starts at 0, 0. So the sine of 0 is 0. So that's going to go here. Okay, and it's going to look like this. So I have another 0 right here. So the sine of pi is 0. And right there. Then I know that it goes in a wave like this. So the sine of pi over 2 is 1. The sine of 3 halves pi is -1. Yeah, it could be worse, I guess. If you look at it kind of in a skiwampus kind of way, if you kind of turn your head, it kind of looks like an S, like a flipped S. And that's how I remember that it's a sine. It starts here, goes like this, kind of looks like an S. Okay, so let's look at it then when it doesn't look so pretty, when we've got a few things added on. Okay, so 4 times the sine of x. This is going to be a vertical stretch, right? So it makes sense that it's going to go up this way. So my amplitude is 4, and my period, again, it is 2 pi over b, and b is 1. So my period then is 2 pi. Okay, so I come over to my graph. Here's 2 pi. It's going to go now from 4 to -4. Not sure how I'm going to write this, but all right, here's pi, because that's in half. Here's pi over 2. Here's 3 pi over 2. I know it's going to start at 0, and I'm going to have a 0 here, and I'm going to have a 0 here. But this time, instead of it just going to 1, it's going to go clear up to 4, and it's going to go clear down to -4. So this one has been stretched. And I guess if it were to to scale like I did the last one. The 4 would be more like up here, and you'd see how it, you know, was a little skinnier. But, yeah. There, now it's going through pi. Okay, so let's now do cosine. All right, just the basic cosine graph. My amplitude is 1. My period is 2 pi over b. So this is 2 pi because it's 2 pi over 1. Okay, and we know this just from the regular graph, right? Okay, so here's my graph. Here's 2 pi, here's pi, I'm going to cut it in half again. Pi over 2, this is 3 pi over 2. All right, and remember, cosine's a little different. It doesn't start at 0, 0. It starts at 0, 1. So here's 1, and I know this from my amplitude, right? Here's negative 1, and it's going to start up here, which means the next one will be one of my zeros. It's going to come down, oops, it's going to come down to negative 1, back up to 0, back up to here. Yeah. Okay, so this is what the basic cosine looks like. And the way that you can kind of remember this is it kind of looks like a C, sort of. I don't know. If these help, great. That's just how I remember them too. But it makes kind of a C in that valley. It's a chasm. It starts with a C. I don't know if that helps. Okay, so let's look at it now. Again, when it is changed a little bit. And this time, we're going to look at one with a horizontal. This will be a horizontal stretch. Okay? All right, my amplitude, 1. My period this time, remember, period is 2 pi over b. Well, b in this case is 1/2. So my period is 2 pi over 1/2, which is 2 pi times the reciprocal, which is flipped. So the period is 4 pi. That's really different than what we've seen before. Okay, but let's graph it. Okay, so instead of this being 2 pi, it's 4 pi. That is the period. So it's 4 pi. Cut it in half. That's 2 pi. Cut that in half. That's 1 pi, or pi. And this is 3 pi. Okay, and my amplitude is just 1 again. So 1, negative 1. Again, this is a cosine, so it's going to have a chasm. I don't know. Okay, so we're here, 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 here. Okay? It looks just like the last one, except it has significantly changed down here. Okay, with the period. Okay, so let's try one now that has a little bit of both, because you'll have ones just like this in your homework. Okay, so we've got a vertical shrink and a horizontal shrink. Again, it's that opposite thing. It looks funky. Okay, so my amplitude for this is 1/2. And my period then is 2 pi over b, and b here is 2 pi. So my period is 1. That sounds really weird, it doesn't have a pi in it, but it's gonna work. I'll show you. I know how excited you are. All right, so instead of it being 1, okay, we normally have 1. This time, my amplitude is only a half. So here's 1/2, here's -1/2, and my period is 1. Well, half of 1 is a half. Half of the half is a fourth. And then between here, I've got 3/4. Well, cosine starts here. It's going to go through 0, down to this point, and to here, and to here. So it's flatter, and it's condensed a little bit. Normally we see a 2 pi there, and it's just a little bit more condensed and a little bit shorter. That is what I have. So your homework has already been put on Big Ideas. We've done an example of every one of the homework assignments, or homework problems. I'm going to try to set up a discussion part in Canvas, so if you've got questions, you can put them there. If you need to email me, you can do that too, and I can try to put those questions on the discussion board, because I promise if you have a question, at least a third of everybody else does too. Okay, I hope this is gonna work. Thanks for paying attention.